morning, viewers. This is Kasturi Day. Today, I'm discussing with the motion in one dimension chapter. This is a physics chapter according to ICSE syllabus, class 9. So I'll start today with this chapter. So before starting, I will request you to please do subscribe my channel, and do the existing viewers, please do stay tuned with me and ring the notification bell so that you can get the notification as soon as the any video is uploaded. Okay, and if you're liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And please don't forget to meditate before you sit to study or you start your day. Okay, it's better if you do it in the early in the morning. That will be helpful for you, and you can also do meditate. It will be in between your works in the whole day also. Okay, so let's start with the meditation first. For meditating, please concentrate on the dot of a point of light. You can concentrate by switching on a bulb in your room and think of that. Think it to be a point of light which is giving you energy, helping you to concentrate on your studies and also doing whatever you do the whole day, helping you to get interested in whatever you do. So let's start with the discussion. So first, the chapter is motion in one dimension. We will go to what is motion. So what is motion? Motion is movement of any object from whether it is a living object or non-living object, but it changes its position from one position to another position with respect to the observer. That is known as motion. That is, when an observer is seeing that body, so seeing an object, seeing a body that is changing its position, from one place to another, from with respect to its surroundings. You is seeing that the surrounding things are at rest. They are not moving, but the object which he is talking about is changing its position. Okay, then the person will say that the object is in motion. For example, if two persons are sitting in a car, okay, and one person is seeing a person who is riding a bicycle outside the car. So according to the person who is sitting inside the car, he will tell but the car is also moving and the bicycle is also moving. But the person who is sitting in the car, he will see the car, the things of the car, the seat, the driver, all of them are at rest because they are not changing its position. But the person who is outside in the bicycle, he is changing its position. So with respect to that person who is sitting in the car, he will tell that the person is riding the bicycle outside the car is moving. But there is another concept that a body is said to be at rest when the object is not, or when the body is not changing its position with respect to the surroundings, immediate surroundings. Like that, for example, in the same example, I will tell you that the person who was sitting in the car, according to him, the seat, the driver, they are not changing its position. So what happens? Those things are at rest. Okay, with respect to the immediate surroundings, the person will tell that the driver, the steering, the seat, like the pillow which is there inside the car, these are all at rest because they are not changing its position, their positions. Okay. Now, if a body moves at a distance in a certain time, which is very large as compared to the size of the body. Okay, if a body which is moving for a very large distance, like the Earth, the planet, okay, the planet which is moving a long distance it is traveling around the sun, orbiting around the sun, but it is covering a long distance. So the in comparison to that, in comparison to the size of the Earth, the distance it is covering, that is very long. So the body, the Earth, is considered to be a point particle. Okay, clear? Next, when a body moves along a straight line path, if a body moves along the straight line path and it is not moving sideways, that is not moving the lateral ways, then the motion is said to be called, said to be one-dimensional motion, motion in the straight line, or rectilinear motion. That is, for example, if a car is moving in a straight road for a longer time, then that type of motion is known as, and not moving sideways, no? So that type of motion is known as one-dimensional motion, motion in a straight line, or rectilinear motion. And if it is moving in a curved path, that is, if it is moving, say it's going to north, then again it's turning towards east or west, like that. So it is moving curved path, curving, the path is curving. So that type of motion will be called as two-dimensional motion. And if an object is moving in the space, like the planets which are moving in the space, the asteroids which are moving in the space, so these objects will have three-dimensional. Okay. Next is how to represent one-dimensional motion. To represent one-dimensional motion, x-axis and y-axis we know in the graph paper. We have x-axis and y-axis. If x-axis is considered to be as a direction of motion, then the one-dimensional motion will be a path which will be parallel to the x-axis. Straight line path along the which is parallel to the x-axis. And each point on the straight line which is parallel to the x-axis will be the position of the particle at different instants. Okay, the position of the particle at any instant t. See, if it is 10 seconds, for example, if it is 10 seconds, then the position of the particle will be here. X-axis, it will be parallel to the x-axis, so it will be here. If it is 20 seconds, then it will be here. 30 seconds, it will be here, like that. So x coordinate will change with the time t. Okay. Next is we are coming to distance and displacement. See, distance and displacement more or less are the same things. One major difference is there between distance and displacement. We will see. So first we will come to the definition, and then we will get to the differences. Okay. So what is distance? Distance is the total length of the path which is covered by the moving body. Okay. Like if it is moving to north, then coming to south, then east, then north, then south, like this, the total distance it is covering, that is known as, it's an M path. The path is like an M. So if it is moving to the M path, through the M path, along the M path, then the distance will be in the M path only. Okay. And it depends on the path followed by the body, and it's a scalar quantity. Now, what is scalar quantity? We will discuss in the next topic. So scalar quantity is there, and it is represented by capital S. CGS unit is centimeter, SI unit is meter. For example, if a car travels east for 5 kilometers, then turns north for another 8 kilometers, the total distance will be 8 plus 5, that is 13 kilometers. And the distance can never be 0 or negative. Okay. Now, displacement. Displacement is what? It is the shortest distance which is traveled by a body from initial to the final position. Okay. Distance, I told you that it will be the total path which it is covering, the body is covering. But displacement is from A to B, it's a straight line, the shortest distance. Okay. So from initial to final position, the shortest distance will be known as displacement. It will have a direction. And that's why it's a vector quantity. Again, I'll discuss this in the next topic. So it is represented by the letter S with the direction. Okay. Like in distance, it's represented by only S, only the magnitude. But in displacement, we will have S written with the direction above head. There will be an arrow in which direction it is moving. Okay. One more thing, distance can never be 0 or negative, but displacement can be negative or 0. And if it is negative, it will show that the direction is opposite direction. Okay. And again, the CGC unit is centimeter, SI unit is meter with the sample. If in the same example, if we consider that if it is 5 kilometers and 8 kilometers, the displacement will be the straight line path, the line joining the two straight line. So next we come to scalar quantities. So what are scalar quantities? Scalar quantities are the physical quantities which only has the magnitude, no direction. Two parameters are considered for this unit. One is quantities measured and the other is numerical value. Scalar quantity is a pure number if it is scalar quantity is a pure number like pi or e squared, then it will not have any unit. Scalar quantities, like other arithmetic methods, are simple arithmetic methods. It can be added, subtracted, multiplied, or divided. Okay. Now, it is represented by English letter symbols like mass. It is represented by small m, time, small t, speed, small v, like that. Example of the scalar quantities are mass, length, time, distance, velocity, density. Next, we come to some vector quantities. Now, vector quantities, what are vector quantities? Vector quantities are those, this is not scalar quantity, this is vector quantity. These are physical quantities which have both directions as well as magnitude. And three parameters are considered in this to express this quantity. First is the unit, the numerical value, and the direction. Okay. The magnitude is given by the numerical value along its unit. It is always positive. The negative sign of the vector quantity signifies the reverse or opposite direction. Okay. Now, vector quantity is symbolically written by English letter bearing an arrow or by English letter written in bold. Velocity is represented by small v, above which there is an arrow pointing the direction, or you can write a capital, a bold V. Okay, V written in bold. Acceleration, small a with an arrow above it, or it can be written as small a, which is written in bold. Force also capital F with an arrow, or you can write capital F which is written in bold like this. Example, displacement, velocity, acceleration, force, rate. Okay. So let us stop here. Next will be the next video will be of this chapter only. I will continue the next chapter, this chapter. So till then, please go through this. If you have any doubt, please do let me know. And do subscribe my channel. If you're liking the videos, share press the like button, share with your friends and colleagues so that they can also be benefited from these videos. And don't forget to meditate. Okay, this will help you a lot. This will increase your concentration. You can also get good marks in your exams. I tell my daughter also to do this, and she is being she is getting benefited from this type of meditations also. So please do meditate. Okay, thank you for watching and have a good day.